Well, thank you for coming to my session about AWS RoboMaker. My name is Alejandra Olvera-Novack, and I work in AWS Developer Relations. So, if you watched the Jetsons when you were young, you probably marveled at the idea of robots being with us in our day-to-day lives. For all of you that are younger in the audience, who might be millennials like me, maybe you didn't grow up with the Jetsons, because that cartoon is from the 60s and was later revamped in the 80s. So if you're unfamiliar with the Jetsons, just to give you a little bit of context, basically they lived in a utopian future. And they had, space vehicles, virtual shopping experiences, and they had a 3-day work week. Can you imagine what you could do with a 3-day work week? Maybe we shouldn't think about it too much. We don't want to get depressed. So we haven't yet reached the stage where everyone has their own Rosie, just rolling around with them at home, although many of us have things like a Roomba, for example. But we definitely are more and more accustomed to seeing robotic appliances in our day-to-day lives. That said, up until now, robotics development hasn't really been very accessible to those who are outside of specialized robotic fields. And if we think about folks who come from a diverse minority environment, it's kind of sad to think that just because you didn't have the same level or chances of education as other people did, that would not permit you to be able to enjoy something cool like playing with robots, right? So as you're sitting here in the audience today, I really hope that by the end you'll have a lot of fun just learning about AWS RoboMaker and how cool it is and all the tools that come with it. But I also want you to think about this. So I don't really care if the people in the audiences are VPs or developers or students or academic researchers. I just kind of want us all to think about how can we all make these tools more accessible for anyone so that we can all collectively help lower the barriers so that anyone can join tech and add to its value. All right, so what are we going to be talking about today? We'll be talking about a couple of customers who are using AWS RoboMaker, although we will be focusing on Leah, the robot walker, right over there. We're also going to be talking a little bit about how the cloud has impacted the world of robotic development. We'll talk about what other AWS services you can integrate with your AWS RoboMaker applications. And we'll also delve back into the initial topic that I suggested of how can we make robotics development more accessible for anyone to join. Then, I'm really excited to also share with you folks all the amazing work that the AWS RoboMaker team has been doing with several high schools and higher level educations. And we're going to talk a little bit about how they're contributing to making STEM more visually appealing to little kids and folks who are in college and so forth. And then, of course, we'll have a fun demo at the end. So, who is using AWS RoboMaker? There's a couple of customers, as you can see up there, but my favorite one, at least my current favorite customer story, is what Leah is doing with AWS RoboMaker. Now, Leah is a robot walker that keeps the elderly safe and active. And with the use of AWS RoboMaker cloud extensions, they were able to use services like Amazon Lex and Polly to enhance Leah with voice commands. Now, I have with me today Eric, actually from Leah, from the Netherlands, is that correct? Let's thank him for coming over to our talk. So Eric is going to show us what the experience is like for folks who need a walker and how much their lives can be improved with something like this robot walker. So Leah is autonomous, first of all. You can actually call it to come to you. You can also tell it to go charge itself. How many parents here, or you don't have to be a parent, how many of you have watched the Big Hero 6 movie with Baymax? All right, quite a few. I'm sure some of it is because you're parents, yeah? All right. So do you remember that the robot could actually go and charge itself? Like, we see these things, when we were growing up with the Jetsons, Disney, and we think about this as, oh, that's such a cool movie. And we forget that, no, these are things that are actually here today in our day-to-day lives. Leah can go anywhere in your house because it actually builds a map of your house environment, just like any robot would do in any other situation that you were wanting it to map your environment. But Leah is also very interactive, and this is what Eric is going to show us right now. So if you look over at the handlebars as he's moving right now, I want you to notice that it is detecting his intention to move. And I'll also want you to notice how the green light turns on. That said, it can also stop in place to prevent you from falling down or tripping.
Please try to walk closer.
It does seem like helpful advice. But the other cool thing is that you can also sit in it. So any of you guys, your loved ones, you're on that long line to the Disneyland ride, and you know your grandma is just so tired, no problem. This is my favorite one, the very last one. Eric is going to show this one, and it's going to make you all laugh. Ready? The other thing that you can do with this, with your awesome Leo robot walker, is use it to help you exercise and dance and do whatever you want if you need extra support. So you can do your dance exercises. Eric, thank you so much. You're amazing. And the last thing of all, oh, not yet. Oh, well. He was just such a good dancer, you couldn't wait to clap. Leah has over 70 sensors. Isn't that amazing? So if you have a grandma or grandpa, some other loved one that you care about, now you know that there are really awesome ways that robotics is enhancing daily experience and lives for people. All right, now we can give a final last clap to Eric for his amazing performance. Thank you, Eric. Now let's talk a little bit about how the cloud is bringing changes to robotics. So what is also AWS doing today that could help impact the barrier to entering robotics? Well, one of the things that I want you to notice on that slide is that barriers to entry can be lowered once you start noticing things like, hey, you know, as technology advances, hardware becomes smaller and faster. At the same time, if you don't have to worry about spending all this money on buying hardware because you can run your simulations for most of your tests and things that you want to work with before you bother deploying it to an actual physical robot, that's another money saver. For example, if you're a student and you want to get into robotics, you might not have the money to go and buy, you know, all these amazing raw spots or this amazing open source rover, which we'll get into in a moment. So AWS is trying to make it easy to write code, robotic development code, with a RoboMaker IDE that was integrated into Cloud 9. We're also making it cheap to run our simulations and our tests. And we're trying to provide out-of-the-box solutions for also managing your fleets of robots. Isn't it cool that we can talk today about managing fleets of robots? I mean, how sci-fi is that? Mike Bell, Executive VP of Devices and IoT at Ubuntu, believes that the use of the cloud will continue to result in lower costs and faster hardware. So you see, it's not just me with this idea. There's awesome VPs out there with the same idea. All right, so I've been amping up RoboMaker, but what is AWS RoboMaker? So the AWS RoboMaker Service Suite is composed of basically 4 main elements. You'll notice that we have support for cloud extensions for ROS. I mentioned earlier briefly the RoboMaker IDE environment, which we'll show in the demo, as well as simulation and fleet management. The IDE that I just mentioned that is integrated in Cloud 9 can be installed with a single click. And for fleet management, we offer over-the-air deployment with AWS IoT Greengrass. And it is the first instantiation of fleet management in cloud robotics. And I think that's pretty cool. All right, so if you go ahead and take a quick look at this diagram right over there, you're going to notice 4 main sections, which is kind of like showing you the typical workflow of a robotic developer using AWS RoboMaker. And I'm going you to notice as well that throughout this entire diagram, there are no pictures of servers or even EC2 instances. Now, I know that we're at Remars, you know, AWS, so obviously we don't expect any pictures of servers are there because we all know what AWS is. But it is cool that we don't even need to provision or worry about our EC2 instances. All the infrastructure is just handled behind the scenes. coupled with the fact that our AWS RoboMaker ID has already an entire development setup for you, we're talking about hours of savings for your developers. So how many folks here have set up an Ubuntu development environment? All right, did it take you 5 minutes? Raise your hand if it took you 5 minutes. What? I want to talk to you after the talk. Okay, raise your hand if you spent more than an hour just to gauge kind of an idea of some of the folks' experiences. Okay, notice that there's quite a few hands raised. It takes sometimes hours or even a day or a couple of days to set up your development environment if you're being very unlucky, and some of us can be very unlucky sometimes. So why not use our amazing tools that make your life easier? Now, the other thing that we'll show later on in the demo is how we run our simulations and how you can spin it up even directly from your browser. So we use Gazebo Client, and Gazebo Client is actually maintained by the same foundation that maintains ROS. And we'll go and talk about ROS in just a moment. Now, let me go ahead and play this sample racetrack simulation for you. So if you take a peek, you're going to notice that in this sample simulation, we're using a Husarian ROS bot, which is the same one that we have up here on stage. And obviously, you're all welcome to come by later and take a couple of pictures. Now, how many of you have heard about AWS Deep Racer? Quite a few. I know, it's trending. I'm actually going to be emceeing later for the final race, so come join the fun. Now, for those of you that might be unfamiliar with AWS Deep Racer, it is an autonomous car that's driven by reinforcement learning. Now, a lot of folks who are enjoying AWS Deep Racer aren't aware of the fact that it's actually using the same simulation environment as AWS RoboMaker. They're both using Gazebo. All right, I mentioned ROS, and now I'm going to get into it. Whenever I give a talk, I don't like to assume that my audience, what the audience does or doesn't know. But I do like to gauge, kind of like to make sure that I give you, the best presentation as possible. Just out of curiosity, how many of you folks are actively working with ROS? Okay, there's a few hands, but not that many. So let's go ahead and talk a little bit about this. Now, before I get into it, I do want to tell you a very short story about how ROS came to be. So almost a little over 10 years ago, there were a group of PhD students who were struggling as researchers, and they noticed that they were constantly being slowed down in their work. And part of this was because a lot of the things that they were doing was manual work. It wasn't really automated. And so at some point, they just kind of stopped, and they started asking themselves this question of, okay, what if we stop doing it the way we've been doing, and we start writing software that could handle all of this work for us autonomously? Oh, even better. What if, after creating that software, we then open source it so that it can be available to all of the developers that come behind us, and they don't have to suffer like we've been suffering? Well, this eventually led to something called Willow Garage. And it's thanks to Willow Garage that now we have ROS, Robot Operating System. So what is ROS? Well, the funny thing is that even though ROS stands for Robot Operating System, it's not an OS at all. It's actually middleware that runs on top of an OS. Now, ROS is a publishing subscription framework, as I mentioned before, open source as it came directly from academia research. It does have the largest ecosystem of packages and tools for robotic development, and overall, it's been the one that's been the most useful to folks. Because it has the largest features and packages available, obviously that means that the largest developer community in robotics is currently actively using ROS. Now, let's talk also about ROS 2. So there's ROS 1, and then currently we're trying to accelerate the adoption of ROS 2. In fact, AWS is actively involved in this. There's an entire org that's dedicated to writing and adding to the packaging system of ROS 2, helping to accelerate its adoption. But let's first understand what's the same. What's the same in ROS 1 and in ROS 2? Well, what's the same is they both work via nodes, messages, publishers, subscribers, and they still work with command line and interface tools and graphical tools. But what's new is that now it's middleware interface, and it's now based on DDS standards. Also, if you note the very first point, you're going to notice that ROS 2 brings data security. Now let's stop and think about this for a second. Am I telling you that we didn't have data security in ROS 1? That's exactly what I'm telling you. That's terrifying. I mean, think about how many times we ship products, features, applications, and we leave things like accessibility and security, and we treat them as add-on features. Not good at all. So that's part of the reason why we're so excited at AWS to keep accelerating the adoption of ROS 2. But it's not just AWS who's doing this great work. There's a lot of industry support. You'll notice other great companies up there like Intel, Bosch, Microsoft, Toyota Research, et cetera, et cetera, et cetera. So what can I do with ROS? I've been amping it up, but what can I actually do? Well, you can find packages for all kinds of things, such as sensors, so like LiDAR and depth camera, which you'll notice that this one has right there. You can also do simulations in 2D and 3D. And I gotta say, that is a lot of fun to work with, although it can be kind of tricky sometimes working in the simulation world for those of you that have already had the joy of doing that. And of course, debugging tools, logging, testing. There are also all kinds of ways in which we can see that these different types of visualizations help us to better understand how the robot is moving through its world. So as you can see, ROS is an incredibly rich ecosystem. And we actually do also think that in terms of robotic development and commercial robotics, ROS could be the equivalent of Linux for robotics. So, you're probably also curious to know what other AWS services you can integrate into your AWS RoboMaker applications. Well, here are a couple of cloud extensions that are already up and ready to go. We already have some apps built with these services, and if you go to AWS under the RoboMaker documentation, which I'll show you the link in a while if you want to take a quick snapshot, you're going to see that there's quite a few apps out there. The code is completely ready for you. It's open source and available for GitHub. You can just download one of these and just start playing with it in the RoboMaker IDE. So you can integrate things like Amazon Lex, Poly. Now, for those of you who might not be as familiar with what we can do with this, Lex is a dialogue management tool. It allows you to build bots similar to how you build an Alexa skill. And you can build then a custom text-based bot. As far as Poly, which is text-to-speech, it'll take any string and then convert it into an audio file in the language of your choice. You can also hook it up with Kinesis video streams. You can do video and image analysis and recognition with Amazon Rekognition. And let's not forget CloudWatch, because those logs are very important for debugging. So I mentioned earlier when I was showing you the agenda of the talk that I wanted to talk about accessibility and robotics development, but I also wanted to tell you about all the amazing work that the RoboMaker team has been doing and working with high schools and universities, not just in the US, but actually also outside of the US. Now, before I do that, I want to tell you a very quick story that I hope you'll enjoy. So this is Amari, and I wanted to share with you that part of the reason why I'm so excited about AWS RoboMaker and all the work that they'll be doing with education programs is because I've seen how much robotics can be a visually appealing way to introduce a younger audience into the area of STEM. It doesn't mean that they're all going to, run off and be robotic developers. Maybe they don't all want to be robotic developers. But there's no denying that there's a huge difference between coding and just, looking at text and then maybe refreshing your browser to see if something changed, versus actually being able to physically touch a robot, right? And then work with the hardware and connect the thing and plug it in the battery. Like, it just kind of feels a little bit more gratifying because it feels more real, if that makes any sense. So to further illustrate you, I'm going to tell you this really short story about Amari. So I mentioned she's my little sister from the Big Brother and Big Sister program. For those not familiar with the Big Brother Big Sister program, it's a community-based mentoring program that matches youths ages from 6 to 18. And a lot of them are predominantly from low-income housing, single-parent households. Some of them have been literally the whole family was homeless and just recently got government housing. All kinds of situations. And they try to match them with, reputable adult mentors to be there for them and support them and coaching. So Amari has been in my life for 4 years now. And the first time I introduced her to tech and coding was I asked her, what's your favorite web page to visit? And she was like, oh, she mentioned some video game, Fortnite, I think it was, right? It's like all the rage right now. And I told her, no, let's just tell me what's your favorite movie. And no joke, she literally mentioned Baymax from Big Hero 6. She's like, I love Baymax, I like Big Hero 6. I'm like, okay. So we went to the Wikipedia page of that, and then I told her, let me show you what HTML and CSS is. And I showed her how to inspect element and how to change the fonts and the colors and make them bigger. And to her, being a 9-year-old kid, she was like, oh my God, this is magic. This is dark magic. How does this work? And then she just really enjoys it. So now she whenever she hangs out with me or she's with her grandma and her grandma texts me and stuff, like her grandma will literally text me, oh, Amari just changed the font colors for the Wikipedia page of X, Y, and Z. Like she really likes doing this. Well, one day, I brought Amari with me to one of those Hour of Code events that Amazon hosts fairly often. And that was the first time that she was actually exposed to a robotic kit. And they had, I think, 3 or 4 different robotic kits, and the kids could play with them. If I remember correctly, one of them was like throwing a basketball up into a hoop. And she just, the first time she was able to successfully program her robot and move it, the first and moving forward, she just went like that. And then she looks at me that look of that feeling as a developer of, it's working, right? We all know this feeling. Hopefully we all know this feeling. And she looks at me and she goes, oh, I'm definitely doing coding when I grow up. But again, she's a kid, so that was followed by, but also basketball and drums. But the fact is, she'd been playing around with, inspecting the element, learning a little bit of HTML and CSS already for 1 or 2 years by then. And it wasn't until she played with a robot that she was like, oh yeah, tech is cool. This is what I'm doing when I grow up. So I just really want us to think about how important visual appeal is to making education fun, to integrating the next generation into tech. And I think that robotics is a way that we can accomplish this. So let's go back to the main topic of the AWS RoboMaker education program and what they've been doing. So the team is continuing to work with leading educational institutions and universities, and they're working on furthering the field of robotics. We're trying to put actual robotics development tools into their hands. How are we doing this? Well, the AWS RoboMaker academic program will be integrated as part of AWS Educate, and they are currently connected with literally over 46 schools. And I'm talking about higher education programs like MIT, Cal Poly, the University of Cambridge, and they're also working with other institutions like FIRST. Is anybody familiar with FIRST Robotics? Yes, so they do all kinds of really cool competitions for those that are not familiar with what FIRST is. And as far as collaborations with other hardware institutions, we've also been working with Husarian, which is this robot right here. And if you go to the husarian.com website, you're going to see that there's already documentation there for setting up your ROS-bot Husarian with AWS RoboMaker. And we are currently updating the documentation as much as possible. In fact, Andrew, a senior developer who's right over there in the background, he's actively been emailing them whenever he finds something in the documentation that's not quite right, he's right on it. So we've been working really closely with them. And we were also able to invest in students by actually donating some of these Husarian ROS-bots so that they could also have hands-on experimentation. Now, I know that some folks are probably curious to know, hey, well, that's really cool, but what are the classrooms actually doing with those Husarian ROS-bots? What's going on? Well, one of the interesting stories that I heard was that apparently for Northeastern University, they're currently using ROS-bots to develop a swarm mapping algorithm. So, as you can see, it's not just, a little kid moving their robot forward and backward and in a circle. They're actually doing really cool things with this. Now, this is a typical pamphlet that we hand out to folks when they want to learn more about the AWS RoboMaker path and the program that we're doing for academics. And I do know that one of the questions I've noticed that I've been getting now that I've been giving talks about AWS RoboMaker is what kind of hardware to get that is compatible with this, Well, basically, really, any ROS-bot should do, it just has to be compatible with ROS that we mentioned earlier. And in the case of the ROS-bots, I mentioned that we've been using for our AWS Educate program the Husarian. So if you're wondering why we were excited to work with Husarian specifically versus other models like a Turtle 3-bot, for example, it's because the configuration and the setup effort for Husarian is definitely much simpler for a beginner. Turtle 3-bots can be kind of hard to get into at first. And then in addition, like the sensors, like all the ones that you need for the basic robot sensors, they're all already there, integrated. So already set to go. You don't need to worry about, adding a camera and things like that. So it's much simpler for beginners to get into it. So if you want to dive deeper, I sent you the link there of AWS Educate. In a nutshell, AWS Educate, if you're not familiar with it, it's Amazon's global initiative to provide students and educators with all the resources they need to learn about cloud. Oh, were people still taking pictures? I can wait. I'll wait. There's going to be a lot of good links there, so. All right, I think we're good. Nope, never mind, more pictures. This is a good link. There's a lot of good curriculum there. If you are a professor or a student, you get free AWS credits, so definitely worth looking into and signing up. All right. I know that you're going to have more hardware questions for me at the end, so just to help you out, I'm showing you some simple places where you can go and directly buy the hardware. The top one is the typical TurtleBot 3 ROS bot that you've probably potentially seen already. That's the most typical one. Then again, a link to the Husarian for those who are beginners and would rather work with a more beginner-type platform. Honestly, you can also just work with a Raspberry Pi. In fact, this current open source rover that I have up here is running on a Raspberry Pi. And then right up here, there is a Raspberry Pi camera. You don't really need that much to get started. And if you were curious to yourself, actually put together this one, you can do that, absolutely. There's a GitHub link with all the information, how to set it up, where to buy the parts, what kind of parts you need. To give you an idea, if you're curious about how long or how much work it takes to put one of these together, it is my understanding that if you're already pretty comfortable with robotics development and hardware, it can take anywhere between 1 to 3 people to set it up, maybe like 80 to 100 hours. But if it's someone who is more beginner and new and just like wants to jump straight into it, it will definitely take you like 200 hours or more. So just to give you kind of like a ballpark game, so that if you do get one and you're stressed about why am I still working on this, you're totally normal. It's okay. All right, let's go back to the main premise. Is robotics development actually accessible for anyone to come in and join the fun with? I kind of think it is now. The more we enhance our tooling and the more we improve our documentation and help people out so that anyone can quickly get into it. So you may remember that I mentioned the premise that as hardware prices are continuing to dropping and hardware is becoming smaller, we're hoping that we can see a bigger explosion of robots, right? Like it should be more accessible. Anyone should be able to get one of these going. But why is that not happening yet? Well, I submit that part of it is because writing the software is very hard. And I think that this is exactly where AWS RoboMaker comes in trying to help things make a little bit easier for everyone, and how we're trying to lower the bar to entry to make it more accessible for anyone. All right, so I promised you a demo. Andrew and I did our very best to produce a quality video for you where we walk you through the general process as a developer if you're working with AWS RoboMaker. We'll show you how to work with fleet management, how to deploy, how to use the RoboMaker IDE, and we'll also show you where in our documentation page we have all of those cloud-based applications that I mentioned the code was all ready for you to just download and start playing with. So I'm going to go ahead and play that video. Wait.
Hi, I'm Alejandra, and I work in developer relations here at AWS.
Hello, I'm Andrew. I'm a software engineer on the AWS RoboMaker team.
So let's talk a little bit about what we're going to be building today. We're going to be working with different components of AWS RoboMaker, and we want to show you just how easy it is to start writing, testing, and deploying robotics software. So we'll go over the development environment and our AWS RoboMaker IDE. We'll show you how to work with the simulations and tests. And finally, we'll show you how to deploy your code to a physical robot.
All right. When you talk about getting started quickly with robot development on top of AWS RoboMaker, one of the best places to start is with our sample applications. Our sample applications are one-click samples of robot code.
I think it's a little bit delayed.
Which you can select, and we'll build out all the infrastructure for you. We've got two broad categories. The first is our Hello World sample application. It's a bare bones structure of all the pieces you need to get together to get started with AWS RoboMaker. The rest of our sample applications show off more advanced robot behavior, like robot monitoring, voice control, or image detection. Basic activities we think most robot developers are interested in performing. In addition to the sample application behavior, we show off the ROS integration natively with AWS services which support this behavior. AWS CloudWatch logs and metrics, Amazon Lex, and Amazon Recognition. So let's get started with the sample application. We're going to choose the navigation and person recognition sample application, and we're going to be using this sample application throughout the rest of the demo. In this sample, we're going to have a turtlebot moving around one of our simulation worlds. It's going to be navigating through the world, and when it sees pictures on the wall, it's going to use Amazon Kinesis Video Stream and Amazon Recognition to identify the person in the picture. So let's get started. Now, in the background, we're using CloudFormation to create the Amazon RoboMaker resources, which you need to get started. We're creating the robot application, which is your robot code, which will eventually be deployed to a physical robot, as well as the simulation application, which is any of your simulation code, Gazebo plugins, or the resources you need for simulation themselves. In addition to the AWS RoboMaker resources that we're going to create all of the other AWS service resources you might need, Kinesis video streams, any Amazon Recognition resources you'll need. So let's jump ahead.
Now at this point, you can see that we have a running simulation. But what does that mean? Now in an AWS RoboMaker simulation, we have our robot code, as well as some simulation code, and the resources all bundled together and running in Gazebo in the cloud. In addition to running the simulation in the cloud, we're also streaming several GUI tools which you can use to interact with the simulation. In fact, if we were to go ahead and use these tools of Gazebo, RQT, RViz, and Terminal, the really cool thing is that all we need to spin them up is our web browser, and we can work with them right here. Now let's talk a little bit about what each one of these is for. Gazebo is a 3D simulator that can simulate populations of robots in both complex indoor and outdoor environments. RQT is a software framework of ROS that implements the various GUI tools in the form of plugins. RQT can be used to build a quick and dirty control panel or a status window for your robot. Moving on to RViz. RViz stands for ROS Visualization. It is a 3D visualizer for displaying sensor data and the state information from ROS. And then lastly, a regular terminal. So let's go ahead and spin up these tools and see what it feels like to work with them. Let's start with our Gazebo client. Now, you're going to notice that what we have here is an apartment world. It was actually built by the AWS RoboMaker team. They've built a few others, such as a bookstore and a racetrack, and they've made it publicly available for you to check out on GitHub as well. What you're seeing here is basically the Kinesis video is using to stream the camera image that the robot has to Amazon Recognition. And here you can see the robot moving around in our environment. Now, one of the cool things about working with Gazebo is that you can actually interact with the elements inside your world. And you can also move them. So for example, if I were to move the floor like that, not that I would want to do that necessarily, but I could move the floor. Maybe I don't want that coffee table over there. Maybe I want to move it over to this side. I can do that as well. Another thing that you're going to notice is that there are actually several pictures inside this world, in this apartment world. Who are these people on these pictures? So these are actually pictures of developers from the RoboMaker team. And what you're seeing here is the Turtlebot is racing through and identifying the different people that are in these pictures. Again, as I mentioned, we're using Amazon recognition for this. Now, let's go ahead and show you what we can do with RQT, for example. So I mentioned that RQ2 has several plugins that are really useful for creating a quick and dirty control panel or status window for your robot. So let's take a look at two of these plugins. First one, let's look at the image view. So this one is really cool because it becomes useful for visualizing data that's coming in.
Oh gosh. No, not again, technology. Please work for me. Let me try this again. Sorry about that.
Bot. Pictures of, we're using Amazon recognition for this. Now, let's go ahead and show you what we can do with RQT, for example. So I mentioned that RQ2 has several plugins that are really useful for creating a quick and dirty control panel or status window for your robot. So let's take a look at two of these plugins. First one, let's look at the image view. So this one is really cool because it becomes useful for visualizing data that's coming in. Using this plugin, you can basically get to see the robot's perspective from its camera feed. In this case, we can see that our Turtlebot is moving through the kitchen. Now let's go ahead and check out another tool that is really useful for this. Let's go ahead and add on robot steering. The robot steering plugin is really useful because you can use it to interact with the robot. So in this case, you can see you can control things like speed. And here we see a lot more pictures of the actual developers, as we mentioned earlier on. Now let's go ahead and spin up the next one, Arvis. This is one of my favorite ones. And I'm not going to lie, part of it is because I have a lot of fun with the different colors that you can play around with in the matrix and the grid here. So let's go ahead and show you what it feels like to work with this. So initially when you spin it up, you can tell that it's basically just a default grid. It kind of makes you feel like you're lost in the matrix. But let's go ahead and add a robot model to our visualization here. All right, here we go. Now, where is this robot? So you probably can't really see it. If I were to zoom in, you might be able to tell it a little bit more, but it's actually moving right up here where my mouse is moving. And the reason why you can't see it very well is because the background of this visualization is black. And as you no doubt remember, the Turtlebot hardware is a dark gray, almost black. So let's actually change the background color to enable us to actually, see our own robot. Now, I'm kind of a huge lover of sage green and mint green, so I'm just going to go with that. And now we can finally see our robot. All right, so it's moving along the grid. And now the grid is kind of hard to see. So you know what? I'm going to change the color of that too. Why stick with gray when we can use pink? All right. And it's little things like this that I think make coding and programming fun. If there are any dad programmers or mom programmers in the audience, don't forget to add a little bit of pink to what you're working with and making, just show your kids how fun your job is. All right, so now we can see the robot moving along our grid. And let's go ahead and add something cool like a laser scan. All right. Here we go. And of course, we have to choose our topic. All right, so you can kind of see it going around now. If I were to zoom in a little bit more, you could probably see it better. That said, it is kind of hard to see all the sensor data, so I'm actually going to change that size from a 0.1 to a 0.5. All right, so what we're seeing here now is we're seeing the view of the laser sensor from the robot. And I think you can appreciate it a lot better and more now that we actually made it a little bit bigger. And RViz is now showing us the different visualizations that can better help us to understand how the robot is viewing its world. And it's really, really fun to play around with, as you can see. All right, now let's go back to the last one and spin up our terminal. So there's a lot of cool things you can do here. As you mentioned earlier, the robot is going through the world and identifying the different teammates that are in the pictures here. In this case, if we were curious to see what some of these folks' names were and learn our RoboMaker teammates' names, we can actually do that. So let's go ahead and find that out. So here we're seeing recognize people, topic. And this is the one that would be able to publish the individual teammates' names. So let's actually go into that and use that one. All right. Now you're going to notice something interesting here. Sometimes the robot can get a little bit stuck. As you can see, is apparently what is happening right now.
This happens a
So
lot.
if we go back to the initial Gazebo client, maybe let's find out where our little robot is stuck. Maybe we can move it and help it out. Oh, there we go. So you can see now that it's actually publishing data, and it noticed one of the coworkers, and it was able to identify it. IC Mayofe. Hopefully I'm pronouncing that name correctly. Another cool thing we could do actually is we can actually tell how fast our robot is moving. We can ask it to let us know. No, as well. And there we go. Linear, angular trajectories with X, Y, and Z axis. All right. So in summary, we got to understand how to use the different simulation tools of Gazebo, RQT, RViz, and now we're ready to talk about our IDE.
When you're ready to start writing code, one of the easiest ways to do that is with the AWS RoboMaker development environment. When we set out to create AWS RoboMaker, one of the things that we wanted to make it as easy as possible was getting started writing code with ROS on top of AWS RoboMaker. And to do that, we paired up with Cloud9 to create a AWS RoboMaker Cloud9 development environment. You can create a development environment on the AWS RoboMaker console on the Development Environments tab. Let's take a look at what that looks like. So if we give it a name, and we can choose an instance type, the M4 large is a great place to start. It's not too big and not too small. And we need to give it a little bit of networking information so that Cloud9 can talk to the EC2 instance that gets created in their account. So once we click create, AWS Cloud9 takes over and it starts to create your development environment. Now what it's doing in the background is creating an EC2 instance in your account with the AWS RoboMaker machine image, our AMI, which has all of the software you need to get started building, bundling, and testing pre-installed. Now let's take a look at one that we already had created. Okay, so when you open up the IDE, you'll see that it looks very much like the AWS Cloud9 IDE, with the exception that we've got some new RoboMaker menu items over here. So let's jump in and take a look at what these offer us. From the Resources tab, we can download the source code for all the sample applications that we were talking about earlier. So let's go ahead and grab the source code for the navigation and person recognition sample application. In addition to downloading the sample application source code, we can view the source code for all of the AWS RoboMaker cloud service integrations. So if we wanted to see the code that's powering the Amazon Kinesis and recognition integration behind our person recognition sample application, we could jump straight to it. So now that the sample application is downloaded, we can see the README page is pulled up, and we can jump right into the code and start to explore. So we've been talking a lot about the robot application and the simulation application. The code in our sample applications is broken down similarly. We have a robot workspace with all the code you need for your robot to operate and which will eventually deploy to the physical robot. And the simulation workspace, which gets bundled into your simulation application, contains all the resources you need to simulate. So let's take a look at the Simulations tab. Now from the Simulations tab, you can connect to a running simulation. And once you've done that, you can stop, restart, and control that simulation straight from the IDE. We can also restart with bundles if we're doing development. And we connect directly to the GUI tools that we were seeing earlier. In addition to being able to control the simulation logs and the application logs, the standard out is streamed directly to the terminal, so you can inspect what's going on while you're developing. Lastly, from the Run menu, there's convenience options for building, bundling, and launching a sample application directly from the menu. And these can be combined into single options which can build, bundle, and launch from one invocation. All right. That's how to create an AWS RoboMaker Cloud9 IDE, as well as some of the RoboMaker specific features of the IDE.
Okay, so we finished the coding, but now how do we actually get our code into the actual physical robot? Well, that's where deployment comes in. AWS RoboMaker offers over-the-air deployment with AWS IoT Greengrass. Our deployment resources are robots and fleets. A fleet is a collection of robots, and the deployments are then made to these fleets. So let's go ahead and jump into an existing deployment and just kind of take a look at what it's actually made of. So I'm going to click one that has already been successful, and we're just going to walk through the way we filled it out to get familiar with it. So we already have a fleet created, and we've taken the time to register a robot to it. So let's walk through creating a sample deployment job. We start with the deployment details. You get to tell us the fleet, the robot application, as well as which application versioning we're going to be deploying it to. Then you move on to your deployment launch configurations. First, you want to pass in the package as well as the launch file. And this is the one that's going to execute on the robot to start the new robot application. Moving on to environment variables. You can specify any environmental variables you want to pass on to the execution. Then deployment settings. So you can actually use your deployment settings to tell us how many robots to deploy to, as well as at which level you wish to fail the deployment. And you can adjust these percentages to match your needs. Then for tags, if you wanted to add any key value pairs, that's always an option. And at this point, you would simply click Create. Now, once you click Create, it's deployed over the air with AWS IoT Greengrass. And you can actually follow the deployment process right here from the AWS console. All right, so if you're ready to check this out yourself at home, don't forget to check out our documentation at aws.amazon.com/RoboMaker. And thank you for your time.
Thank you so much for your patience with the technical issues. If you have any questions or you want to talk to folks from the actual AWS RoboMaker team, please don't be shy. That's the best email address for them to get back to you. And I'll leave it up just for a quick second. Thank you so much. I hope you enjoyed learning about AWS RoboMaker. How many of you guys want to go home and try it out now? Good answer. All right. Thank you.